Hello everyone. My project is Home Automation presented by Nandini Ji, third year IT department from Tech Multitech Dr. Rangarajan Dr. Shakuntala Engineering College. My project is based on IoT and what home automation is, and a system use is embedded system includes microcontroller, and use of an user interface application is a Blynk, and the requirement for the project and project phases and the methodology of the project and the conclusion. Let's see what IoT is. The Internet of Things describes a physical object with a sensor and the processing ability of the software and other technology that connect and exchange the data with the other device and system over the Internet or other communication networks. That is, the physical object with a sensor, the processing ability of the software with exchange the data with the other device, the system over the Internet. With, it's a form of communication between them. The Internet of Things helps the people's life smarter, but it gains all the control over their lives. The IoT device shares a sensor to the collector from an IoT gate where the data is sent to the cloud where it will get analyzed and the device communicate with other related device and act on the information they get on from them. The benefits of an IoT is monitor the overall business process, improve the customer experience, save time and money, enhance the employee productivity, integrate and adapt business models, make better business decisions, and generate more revenue. Let's see what home automation is. Home automation is constructing a automation for the domestic purpose such as smart house and sensible home. In IoT, the home automation ecosystem can control the device like fan, light, TV, and so on. The domestic automation system monitor and manages our home attributes by adoring the lighting, sense of climate, enjoyment system and appliances. It is very helpful to control our home devices. It is going in addition to the security purpose, acts as an access management and alarm system. Once it is coupled with an internet, the domestic gathers a very important consequence of the life of the person of Internet of Things. A domestic system usually connects and control the device to a general hub or a gateway, which means the program can control the system and makes the all wanted mount terminals like tablets or desktop computers or an online interface may be an approachable offsite through the internet. Let's see what is embedded system. Embedded system is a combination of hardware and software which is intended to do a specific task. The embedded system is a microprocessor based computer hardware system with a software that is designed to perform a dedicated function either as an independent system or as a part of a large system. At the core is an integrated circuit designed to carry out the computation of real-time operation. When classify the embedded system based on their performance and functional requirement, embedded systems are divided into four categories, that is real-time embedded system, standalone embedded system, network and networked embedded system, and mobile embedded system. The embedded system connects input ports, system core of input ports, and memory and other device are a vice versa method, and the output given out. See the microcontroller and microprocessor. Microcontroller is a single chip of VSLI unit, also called as microcomputer, which although having a limited computational capacity, possess and change the input-output capability of number of on-chip functional unit. The CPU contains an I/O port, RAM as a timer, and ROM as a serial COM port. The microprocessor is a single VSLI chip having a CPU. In addition, it may also have other input units such as coaches, float point, processing arithmetic units, and pipelining units which helps in faster processing of the instruction. See, the microcontroller we gonna use in this project is microcontroller ATmega32AP in Arduino UNO board. It has a 14 digital input and output pins, of which 6 can be used as an pulse width modulation output, 6 analog inputs, and 16 MHz of ceramic resonator, and USB connection, a power jack, and ICSP header and reset button. Let's see the ADC block and DAC block. ADC block is an analog to digital converter, takes analog wave as an input and converts the wave to a digitally represented output form, where the digital to analog converter expression does not reverse, converting the digital representation into an analog form. The timers and counters in this project is a pulse width modulation. It's a technique of getting an analog result with digital means. The digital controls is used to create a square wave, a single switched between on and off. The on and off pattern can be simulated voltage in between the full VCA of a board and off by changing the portion of the time the signal spends on versus the time speed spends on the off. The duration of on time is called the pulse width. Let's gonna see about the user interface application in our project is the Blynk platform. Blynk is a full suite of software required to prototype and deploy and remotely manage and connected electronic devices at any scale, from personal IoT projects to a millions of commercial to connected products. With Blynk, anyone can connect their hardware to cloud and build no code with an iOS or Android or web application to analyze the real-time historical data coming from the device and control them remotely from anywhere in the world and receive the important notification and much more than that. Let's see how to create a template and add a device in the Blynk console. Open the Blynk console in the browser, create a new template, create an account in it and create a new template, add a new device to it where we can fetch the data and add new data stream where we control our mobile app, and copy the template ID and device ID and authentication token. With this is a file configuration where we gonna use in a C program in a project. The requirements for this project as hardware as well as software is the hardware component we use PICSIMLAB, contains Arduino UNO board, LDR sensor, LED, LCD, LN35 temperature sensor and temperature system, Ethernet shield and serial tank. It is based on all else simulation. For a software we use Arduino software, Blynk app, internet and basic embedded C program we gonna use it. The aim and goal of the project is to control the heater and the cooler remotely, to control the LED during the day and night, to control the water tank through the internet, to create the home automation system. To create a home automation system. The project phases, we're gonna see it there. First we're gonna do a programming base for a project with the C program, and later on we're gonna use a microcontroller that is 3280, and use of Arduino board in an embedded system with spare parts, and with an and later on with the Blynk app we gonna control it all. The methodology of the project is first we gonna set up an output layout, and then we connect with an Arduino board, and the Arduino board is connected to the Blynk console to do an operation, and then the Blynk console is been connected to our Blynk app in a mobile. From the Blynk app we gonna connect Blynk cloud server to do the necessary things, and we need to lighten a LED. Likewise, then from the Blynk console servers is given to the Arduino board, given a command to do the work, and later the LED blinks in a house. Likewise, for the temperature control system and water tank inlet, where the Arduino UNO board sends a temperature to the Blynk IoT app. From there, we know about we can control the heater and the cooler. When we need to do the heater means the Arduino UNO increase the temperature of the temperature system, and the heater is in control with it, and later gets a maximum temperature. We can the Arduino UNO gives a notification to the Blynk IoT app. The Blynk IoT app gives a notification to the CLCD and the current temperature to the CLCD. Likewise, for the water tank inlet and outlet value controllers, the Arduino UNO tells the volume of the current volume of the water. From the IoT app, we gonna outlet the water, the Arduino UNO board outlet the water from the water tank and gives a notification to us that the water has been outletted, and then the current water level will be notified to the CLCD. Likewise, the process will be occurring. Let's move on to the project demo. Hello everyone. We are in a phase 1 where we're gonna see about a C program in our project. I'm in an Arduino software where I already implemented my C program in it, and I've also created the C program for LDR sensor and the header file for it, and the main.h for the pins we're gonna use in it, and for a serial tank C program, header program for temperature system C program and its header program. And I've already introduced installed installers in a program, that is Blynk, Liquid Crystal I2C, and UAG library for a program concern. And I'm already said we need to copy the Blynk template ID from the Blynk console. That code will be pasting here for the identification of the device we gonna use. Then that's it. We need to run the program. Compilation is done. Compilation is done successfully. So we can do a project, the PICSIMLAB. Now we are in PICSIMLAB. It is the board we're gonna use in this project. It is an Arduino UNO board of microcontroller ATmega328P, and these are the spare parts we're gonna use in this project. This is the spare parts. This is the LED. So LED. This is the LCD we gonna use. This is a temperature system. It is an ETH for sensoring, and it's LDR sensor, and set serial tank. Serial tank. Gonna use it. Terminal to check whether all the parts are correct. That's correct. Set and it's ready. Install. We can keep a Blynk app aside to control it. Right. We will load our X file in it. Let's see the output. See the inlet value, the water increases. Sets its maximum level. Yeah, it's a maximum. If we outlet it, the auto on. Whether we off it, stop. It's about the heater. It's on the heater. The temperature increases. Reach the maximum temperature, I think. And if we pulled off using the rover cooler, the temperature decreases. And for a LED, as in daylight, the LED reach a maximum temperature where when the temperature reduces, when it reduces the daylight, the lamp blinks. Totally we outlet it. That's it. The demo is. Let's see the scope of the project and the conclusion. Now we are in a last part of the project is the conclusion. Last we're gonna see what we learned from this conclusion, what we did in a conclusion in our words. The home automation should be simulated on the PICSIMLAB simulator as I did in a Blynk IoT mobile application I used to control the devices should be able to control the light, temperature of the home and inflow and outflow of the water in the water tank. Using Blynk IoT application and PICSIMLAB simulator simulate the home automation where the LED temperature system serial tank resembles the light, temperature, cooler and water tank in a real time. The CLCD act like a dashboard used for displaying the event and Winked from the Blynk IoT app like buttons and Winked are used to control the heater and cooler and inlet value and outlet value. And the gauge will set the display the temperature and the volume of the water. That's it. And thanks for all. Thank you.